Hello, Professor Sargent here with you again. We're going to talk about using the rational zeros theorem and synthetic division to factor polynomials and find all the real zeros. Now, in this example, I would like to show a second option shortly, but first of all, we have found that the possible rational zeros of this function would be of the form factor of the constant over factor of the leading coefficients. And so since both of those are prime, here's the factors of the constant and then of the lead coefficient there. They can be positive or negative. Then when we start pairing these up, 1 over 1 reduces to 1, 1 over 2, 3 over 1, or 3 over 2. If you include the positive negative there, we've got 4 times 2, or 8 possibilities. And in fact, if I put those in order, we'd have these 8 possibilities. No, that does not mean that all of them check. It may be that none of them check. At most, 3 of them could, because this is degree 3. So you could use a graphing calculator and look for where we have an x-intercept. Give me a moment and we'll do that. All right, so let me type in the function here, 2x cubed. Let's see here, 2x cubed minus 3x squared, 2x cubed. It doesn't like me using the keyboard. Minus 3x squared minus 2x and plus 3 . Now, you could have irrational zeros, but since I put these in order, if we have rational zeros, integer over non-zero integer, then they'd have to be between -3 and +3. And so I'm going to choose a window that just goes a little bit further left and a little bit further right. -4 and +4 here. Since we're looking for x-intercepts, we want to see y values around 0. And so I could focus in on that by going -1 to +1. Now, it looks like maybe we have a crossing at -1. That's not proof. And in fact, pressing second and above trace is calc. If you choose the 5th option, we've only got one curve, so I'll press enter and enter again. Oh. Second option. Okay, left bound. So left of -1, say -2. And a right bound, say, let's go with 0. Doesn't seem to be anything else in between. Even this is not a proof. That could be round off error. So we've got to actually check it using synthetic division. So trying out the -1. We don't have any missing powers of x. It goes 3, 2, 1, 0. So 2, -3, -2, and 3. You bring down the first entry to the very bottom, and then it's multiply and add. Multiply and add. This tells me two things. Since I get a remainder of 0, x equals -1 is a 0. And I expect there was going to be more here. But furthermore, it gives me a factorization. The associated factor with x equaling -1 as a 0 is x plus 1. Then because I divided a cubic by a linear, degree 3 by degree 1, my other factor is quadratic, degree 2, 2x squared minus 5x plus 3. Now to find other zeros of this function, since we have this quadratic, you could try factoring. You could try completing the square. You could try the quadratic formula. But suppose that you want to keep trying synthetic division. Don't go back to the original. Do not go back to the original. Go to the factor remaining that is not linear and start synthetic division there. Now, if I show you the calculator again, it looks like maybe we have another 0 at +1. Again, that could be round off error. So verify by synthetic division. Just use the coefficients from that remaining factor. Bring down the first entry and then multiply and add. Multiply by what's outside times the current entry in the bottom row and add. And that gives us that +1 is also a 0. We can break this down even further. X minus 1 would be the factor that goes along with this as a 0. And then we have, since that's degree 2 divided by degree 1, our remaining factor is also degree 1 or linear. And if you set that equal to 0, you can see I have already typed out the solutions. 2x minus 3 equals 0. 2x equals 3 after adding 3 to both sides. Then divide both sides by 2 to get 3/2. All right. There'll be more coming along in a bit.